Welcome back. Now, this is the Doppler effect question. Okay. A police car with its siren of frequency 1200 Hz on is moving at a speed of 18 meter per second towards a high wall. Okay, a police car moving towards a wall. The speed of sound in air is 343 meter per second. Okay, this is the speed of sound in the air. Calculate the apparent frequency of sound that is reflected from the wall. What is actually apparent frequency? Apparent frequency is the observed frequency. Okay, the question asking about apparent frequency means the observed frequency. Observed frequency. Okay, so he give you the actual frequency. See the source frequency. This is the siren frequency. He already give you. And this is the siren frequency. So this Fs, the actual frequency. And this speed is 18 meter per second. This one is the speed of the siren. Anyway, this is the speed of the source. Okay, this is the speed of source, speed of the siren towards a high wall. Okay, so what is the I already the frequency of the source 1200. This one, speed of sound, speed of source. Okay, I haven't write down the speed of source. Speed of source, yeah, is 18 meter per second. You know the source is moving. The source is the siren, the police car. The police car with the siren is moving at this speed of source, 18 meter per second, towards a wall. Okay, so now for the A, what is the apparent frequency that is reflected from the wall? That means now the police car act as the source of the sound because it got siren. Okay, it emits the sound towards the wall. Okay, the police emits the sound towards the wall. So the wall is the observer. In this case, the wall is the observer receiving the sound from the police car siren. He receiving the sound from the police car siren. So the wall is the observer. Yeah, waiting to reflect the incoming wave. You want to reflect the incoming wave. Okay, so the process one is the police is the source, the wall is the observer. Okay, receiving the wave. So in this case, the source is moving. Okay, the source is moving towards the observer. The source is moving towards the observer with 18 meter per second. Okay, so we want to find the frequency observed by the wall, which is equal to V over V Vs Fs. So, the source is moving. Yeah, the source is moving. So the source has velocity. So at the top here, no velocity of observer. Observer is not moving. Only the source moving. So we have Vs below. So source moving towards. This is a source moving towards the observer. So do you expect the frequency to increase or decrease? If towards is always increase, expected to increase. Anyway, it will also compress the wave, isn't it? Towards the wall, it compress the wave, so the frequency will increase. We expect it to increase. So this one should put plus or minus. Plus or minus. We want to make frequency increase, then the below here must make it smaller, isn't it? Divide by a smaller value. In order to divide by smaller value, you minus lah. You minus, then it becomes smaller. Then the frequency becomes bigger. That's how we determine positive or negative. Okay, let's continue. Yeah, this V is the speed of sound, 343. Okay, So just put a 343 there over 343 minus the speed of source is 18. Okay, and then the actual source, the actual frequency of the sound is 1200 hertz. So I heard 1266.46 hertz. So this is the frequency observed by the wall. Yeah. This is the frequency observed and reflected by the wall. Okay, frequency observed and also reflected by the wall. So the second question, the apparent frequency sound detected by the driver of the police car. Why this time the police car will detect the sound? Yeah, because now the wall reflect the wave. Just now he observed the wave, he observed this frequency. Now he also reflect the same frequency. I observe this frequency and he reflect the same frequency. He reflect also the wave that is already compressed. So for this second process, the wall, because it reflect the wave, so the wall become the source. The police car now can observe the reflected wave. Yeah, the policeman now can observe the reflected wave by the wall. So the wall is the source, the policeman is the observer. Okay, so now the speed of the observer is the same as the speed before, 18. So you see, the policeman, the police car has two functions. First time it functions as the speed, as the source. First time it functions as a source. Now the police car also function as an observer. So this question has two processes. He emit the sound. Now the police emit the sound. Now the police also receive the reflected sound. Okay. So now the police car is observer. He's still moving at the same speed as before, 18. So now this 18 become the speed of observer, not the speed of source anymore. The source, which is the wall is stationary. So that's why the formula, we don't have Vs anymore. Because the wall is stationary, the police is the observer moving towards the wall. This person is also moving towards, this observer also moving towards the wall. Observer moving towards the wall. So towards the frequency always increase, isn't it? Further increase. So you want to increase frequency. So at the top here, you need to plus or minus. You need to plus or minus. Of course, if you want to increase the frequency, that means the top one need to make it bigger. How to make it bigger? We plus. So the thing will become bigger. Okay, that's how easy to do it. So now 343 plus 18. That's the velocity of observer. 343. The frequency that he received is the reflected wave. Is the frequency reflected by the wall, which is observed by the wall initially, which is 1266.46. Okay. 1266 it's not the 1200 anymore, yeah, because the wall observed the frequency that is already increased. Now the frequency is increased some more, yeah. Okay, so that's it. Now what's the answer? It's 1332.92 hertz. Yeah, this is the frequency heard by the policeman. Okay, when he receiving the reflected wave from the wall. Okay, so that's all for the first question. Stay tuned for the next one. Bye.